Hello, Math 7 students. We are now starting Module 3, Lesson 3, and it is called Writing Products as Sums and Sums as Products. It can be found on page 81 of my comp book. So here we go with today's lesson. Writing products as sums and sums as products. The goal for today we are going to learn how to apply the distributive property and undo the distributive property. The question that I want you to be thinking about is, what number can you multiply by anything? And the answer is the number's opposite. A quick review. This is going back to the beginning of working with ratios and proportional reasoning, and you'll see that by incorporating the tape diagram. A sum of the money was shared between George and Ben in a ratio of 3 to 4. If the sum of money was $56, how much did George get? And they're asking us to use a tape diagram to solve this. So I want you to take a look at this tape diagram that we have right here, and we know that our ratio is 3 to 4. So we know that George has 3 sections, and we know that Ben has 4 sections, and all of the sections are the same size and the same shape. So we know that whatever goes inside them has to be the same for all sections. All of those added together gives us 56. So what we have to figure out is what would be the value that is represented in each one of those squares. And so if we take another look at this and we have 3 to 4, the question that I want you to be thinking about is, what does the rectangle labeled X represent? This little section right here is represented at X. It could be any of these sections because remember, a tape diagram means that all sections are the same size, same shape, has the same value. So we know that each one of these is X. Well, the way that we figure that out is we have to count how many sections there are, and we know that all of those equal 56 together. So if we count them, we have 1, 2, 3, 4, 5, 6, 7. We have 7 of X, and all of that equals 56. So if you look at it like this, what you're actually doing is you're using the distributive property to figure out what X would be. And so we know that we have 7 X's. Well, if we have 7 X's, then we need to know how much goes in each of the boxes. So we take 56 and we divide it by 7 because there are 7 boxes, and we get 8. So we know that in our tape, we need to put in each one of the sections, because remember, each section is the same size and the same shape, so we know that 8 goes in each one. So we have 8 in each one of the sections, and then we can figure out what both George and Ben have. So we know that there are 3 8s, so 3 times 8 equals 24 for George, so $24 for George. And we know that Ben is 4 times 8, which equals 32, so Ben has $32. Now, it didn't ask us what Ben wanted, but it did ask what George had, so George was $24. The way that we would link this back to the distributive property is we have 7 X's, and X's represent the sections of the tape, okay? And so that's how it's related to the distributive property. Let's try another problem and see if it helps clarify it a little bit more. So this one, it says use the distributive property with tape diagrams, and what they want you to do first is they want you to represent 3 plus 2 using a tape diagram. So if we're going to use a tape diagram, and it's not a ratio this time, so all we have to do is draw one piece of tape. And in that one piece of tape, we need to have 3 sections. There's 3, and then we have to have 2 sections. So this amount right here to here represents 3. This amount from right here to here represents 2. And so it's showing in that expression 3 plus 2. And we know that it's being added because it's all in the same tape. So this section right here represents 3, and this section right here represents 2. So we have one group of 3 plus 2, okay? Now it says that we want to represent X plus 2 using a tape diagram. Okay, well, so we have a tape diagram like this. X is the unknown amount, so we could say that this represents X plus 2. So right here, this would be X, and this right here would be 2. And we don't know what X is, so we just drew a size, but we don't know what it is. So we can't divide it into parts. But we do know that it's being added because it's all in the same tape. So x plus 2 would look like this in a tape diagram, okay? And then what we need to do from there is it's saying, how would we use the tape diagram to show the quantity of 3 plus 2 3 times? So basically the way that you would show that is by taking the same tape that we did up here, but we're going to do it 3 times. So we have this tape. Remember that it has 1, 2, 3, and then 1, 2, right? And then we are going to do that how many times? 3 times, because it says 3 times. 1, 2, 3, 1, 2, and then our last one of 1, 2, 3, 1, 2. So all of this right here to here, all the way up, right, and all the way down is 3 plus all of it to right here is 2, right? But we need to see how many we have. So how many do we actually have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually 9 plus 1, 2, 3, 4, 5, 6. There we go. So that is how you use the distributive property to show with tape diagrams. All right. So then the next one says, how do we show 3 times the quantity of x plus 2? Well, we do the same thing. We draw our tape. Here's x, here's plus 2, and we have to do it 3 times, right? So here's x, here's plus 2, one more time, right? Here's x, here's plus 2. So remember, this section right here is the x. This section right here is the plus 2. So 1, 2, 3, we have 3 x's plus 1, 2, 3, 4, 5, 6. And that's how you get this 3 times the quantity x plus 2 simplified into that. And this right here was 3 times of 3 plus x plus 2, and you get it simplified into that. Okay, so this is all the distributive property. We're just using tape diagrams to help us see it. Okay, so now the next thing that I want to show you is what is the area represented by the sections of the tape diagram. So basically what you're figuring out with area is you're taking the length times the width, the length times the width. So the area for the pink rectangle is 3 times x. The area for the blue rectangle that you see is 3 times 2. And the reason why that works is because we have 3 x's, so that's 3 times x, and we have 3 of the 2's, so 3 times 2, 2, 2. So that makes 3 times 2. Okay? So we're using the area model to help us with the distributive property. Okay? Have to turn the page. Sorry, they're stuck together. Okay. So now, if we take that information that we just looked at and we try it, it says, so the distributive property means to multiply all parts of an expression by the coefficient. Remember, the coefficient is the number that sits next to the amount that's being multiplied. So we have 11 times the quantity of 16 plus 5. So if we have 16 of them right here and 5 of them right here, we have to do that 11 times. So when you draw that out, it gets kind of crazy. But you basically what you're saying to yourself is you are taking 11 times 16 plus 5. So you have the tape to do that. So that means that I have 11 16s plus 11 5s. And so that gives us a very large answer of 11 times 16, 6, 6, 1, 1, 176 for this one. And 11 times 5 is 55. And then we can combine those both, and we get 231 is our total. Now, what that would be is if you had drawn all of these out with the tape, you would have 231 little boxes in your sections. Okay? Taking a look at the next one, it says, how could we write this with the distributive property? So basically what you're doing right here is you're working backwards. So this is the undo of the distributive property. So we have x plus y. How many times do you see that? 1, 2, 3. So if we were to draw tape, we're going to say this is x and this is y plus this is x plus this is y plus this is x plus this is y. So that means we have 3 x's plus 3 y's. And the way that we can undo that even further is, what is the section of tape, x plus y, and then how many times do we see it? We see it 3 times. So that's working backwards with the distributive property, which is what this example is asking us to do. Okay, how about this one? What would this one look like right here? So we have a tape that looks like this, and it says x plus x plus x, right? Plus another tape that says y plus y plus y, okay? So then basically what we see right here is we have 3 x's plus 3 y's, which again, if you were to undo that some more, you could say that you're doing x plus y 3 times. Okay, so again, it's another way to show what we're doing. The last one says 3 x's and 3 y's. So if we have that, let's say that this is x and this is y, and we have it 3 times, right? So this is x and this is y, and one more time. This is x and this is y. So how many times do you see it? 3 times. So you have 3 times. What does one tape look like? X plus y. And there again is another example of undoing the distributive property. Okay? The distributive expression is often called standard form. So that's something else that you need to know once you distribute it out. So here is not distributed. This, however, is distributed because we actually took 3 times x plus 3 times y, and this is what it looks like in standard form right here. Okay? All right, so moving on to this, it says, how do you undo the distributive property? And we're actually going to try it with numbers this time. So the standard expression that we're going to be working on is 8x plus 4. So we can use a tape diagram to help us with that. Think, what do both terms have in common? So looking at this 8x and looking at this 4, you should be saying, is there a number that goes into 8x that also goes into 4? What does it mean to factor something out? 4 goes into 8 evenly, and 4 goes into 4 evenly. So we're going to factor out the 4 from both terms. So you have to think to yourself, here's the expression, 8x plus 4. If I divide 4, I get 2. If I divide 4, I get 1. So basically, you take the factor that you divide from both of them, set them on the outside of the parentheses, and then what you have left is what goes inside. So 8 divided by 4 is 2x. 4 divided by 4 is 1. So we would have 2x plus 1, all quantity multiplied by 4. Undo distributive property is what this is, and the expression as a product of 2 factors is what this is. Okay? So what I would like you to do on this one is I would like you to try these 3, remembering that you have to find a number that goes into both of them evenly. So I will help you with the first 2, and then your homework for tonight to finish up these notes is to try these other 2 problems. So if we have 72t plus 8, what I have to think to myself is, what is a number that goes into 72 and 8 evenly? Well, I know that 8 can be divided by 8. I also know that 72 can be divided by 8. So the factor that goes into both of them is 8. So that's the number that sits outside the parentheses. And then I have to do the math. 72 divided by 8t equals 9t, good, plus 8 divided by 8 equals 1. And so now I have just factored it out. So that's my answer, okay? So you're going to do the same thing with 36z and 72, and you're going to do the same thing with 144q minus 60, the same thing. And I want you to practice those, okay? The distributive property is actually really fun, and the tapes are just a tool that we use to help us see it, okay? So let's go back to our goal. Our goal was, today we are going to learn how to apply the distributive property, which we did, and undo the distributive property, which we did. What number can you multiply by anything? And the answer is the number's opposite. The answer to that would be multiply it by a negative 1, okay? A negative 1. All right, my darlings, that's it for this video. I will see you all later. Bye.